The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
Hello. Ooh. Okay. Podman, Quadlet, and Ansible. So this presentation, I just want to let you guys know, it will have some code demonstrations. If you can't see it or it's hard to see, these can be followed along on your phone. You can go to the bottom link and the slides are there. The slides also downloadable in code form and markdown from GitHub. And also the code that makes the GIFs can also be, there are GIFs in here for the demonstrations. Those can be downloaded and you can see the commands that were run and all that. So there you go. Show of hands, does anyone here in here not know what a container is? So we could potentially speed this up if you guys don't want to sit here for the whole time. About a quarter of this, maybe less, is just a little bit of an intro of containers. So we'll see what happens. You guys, I guess, already know what a container is. So for those maybe online, a container, I'm going to read the slide. The containers package applications together with everything they need to run, including their full runtime environment and required files. Podman. What is Podman? Podman is Red Hat's container solution. It is a tool used to run, manage, and create containers. It is unlike other ones. It is daemonless, so it doesn't need any background services to run. And it does not need root privileges. So very cool. What is a pod? A pod is a collection of containers that run together and share common resources. So a simple example of this would be, we're going to look at WordPress in a little bit as an example. So you would put the application and the database into a pod, and then they talk to each other over localhost. So that would be one simple use of a pod. Simple example. And what is systemd? This is the controversial slide. It is a core part of the Linux system, depending on who you ask. It is a core part of how Quadlet works. So if you want to use Quadlet, you have to use systemd. I think we all know what systemd is. It manages services. It starts everything. It runs as process one, PID one. So. And Quadlet is an integration of systemd. So there's no way around. If you want to use Quadlet, then you want to use systemd. So what is Quadlet? Quadlet, does anyone here know what Quadlet is? Has anyone used it? A little bit. All right, so this is where we're getting into it. So Quadlet simplifies systemd integration. It reduces a full systemd service file down to the essentials, which are basically just the dependencies on other services or containers, if you choose to define that, and then the Podman configuration. The way you would do this with systemd beforehand is you'd have to write the whole service file yourself. Depending on how simple or advanced they are, that could be good or bad. They started simple. There was a generator at one point and that you could run to just spit out a simple systemd file, but they found that it didn't really work well because there's a lot of text that needs to go in there that I'm not going to go over, but like especially under the exec run parts. So anyway, Quadlet is the answer. So you can work on the human part, just do the little stuff that you need, and let Quadlet handle the rest of the stuff that goes in that service file. Does anybody have any questions about that explanation? Okay. Okay, and then we're going to orchestrate this with Ansible. So what is Ansible? Does anybody have Ansible experience? Most. Okay, cool. Ansible is an open source command line automation tool. Its main advantage is being able to talk to almost anything. And the way that it talks to Linux hosts is usually over OpenSSH. It can talk to Windows over WinRM, and I think a different method. We're not talking about Windows today, though. So we're going to orchestrate this stuff with Ansible today. How can these tools work together? So our pods and containers are going to be defined using Quadlet. Quadlet can be organized into logical groups through an Ansible inventory. Ansible can configure the host system. Ansible can deploy the Quadlet files using the inventory. And then systemd detects the Quadlet files and manages the pods and containers and services. So we're going to define everything and then let Ansible put the files into place. And then systemd will just pick up the Quadlet files and do what it's supposed to do. And then we can also, obviously, half of the point of this, right, doing it rootless. So does anybody have questions on that part?
Do you use a hack where you tell Linux not to make the privilege ports require things, or do you have to do the EIP thing where you change the cap capabilities?
So you want to give him the mic? Yeah, sorry. Do it again.
Yeah, for things that need to bind to like port 80 or privileged ports, do you either put in the kernel parameter that says that anyone can bind to port 80, or do you do the set cap?
We're going to do the sysctl and change where the unprivileged port maps start. Range, not map. So you'll see it in here. Okay. So how are we going to be using rootless? How are we using rootless? So in our examples, we're going to be using a dedicated user named containers, because that's not going to be confusing, talking about containers and containers. And this user will have, it's unprivileged, so no password, no SSH keys, no sudo access, no way to log into it from externally. That's how I'm using it. That's not a requirement. That's how we're just doing this example. Trying to make it as locked down as possible, just to prove that we can do that. And we're going to be switching into this user to run the containers manually, and then also with Ansible later. So, okay, and then this goes to your question. What is the bare minimum? The bare minimum, the first part is enabling systemd linger. So by default, systemd will stop a user's processes if they're not logged in. And it will not start them like on a reboot or anything. It just ignores them. And then when they log in, then the things will activate if that's what they're supposed to. We got a question.
I'm probably the only person on the planet that'll ask. Does it work with IPv6 as well?
I don't know.
Okay, thanks.
I have not tried IPv6, so that is a great question.
What about the privilege thing?
His question was about the IPv6 unprivileged ports. I don't know. I'm basing just on this. I would assume there's one called IPv6, but I don't know the answer to that question. That link at the bottom of this page, this is where these, I wouldn't say best practice because there's more than one way to do it, but this is where this example came from. So I don't know if there's an IPv6 equivalent, but I'm going to say probably. So the linker is very important. That's burned me once. Anyone that's tried rootless gets confused by this. You got to turn the linger on, and you have to specify the user, or else systemd will just ignore your services. And this goes not just for containers, for any user service at all. So, and then the answer about the ports, we're going to be using sysctl to tell the system the privileged port range start is less. So we're backing it up all the way down to either port 80 or 22 or whatever you want. And again, the link at the bottom, these examples come from there. So in the case for our WordPress, we're going to back it up to 80 so that we can have 80, 443, and everything above that. Unfortunately, as far as I know, there's no way to make it more granular, like a firewall, like only allow these. But I mean, we're talking about the port range of an unprivileged user, so on the host that's already supposed to be locked down. So it's probably negligible, but it's worth mentioning, yeah. Okay, so this is going to be a GIF of us just doing that, just to see what it looks like. Just a couple commands. The first one's a simple command, just like we saw. The second one, we're actually echoing that text to a file, and then we're having sysctl load that file. So there's more than one way to do that. That's just the way that I'm going to do it, putting into sysctl.d, putting in its own file. So does anybody have any questions about that stuff? Okay, and feel free to interrupt because it can be a complex topic, and so just raise your hand at any time. Okay, so how are we switching users? This is different maybe than other people than you've seen before. Most people have seen, they don't use this tool. But we're going to be switching into the containers user with a tool called machinectl. This tool doesn't come standard, and I forgot to put the name of the package, so you're going to have to figure out what the, you could do like a DNF provides machinectl. I think it's systemd-containers or something like that. This tool is powerful. It does other things than what we're mentioning here, but we're using it to switch into the user and open a shell. And the reason we're using this is because if you do sudo su or su whatever, the dbus doesn't start. And if you don't connect to there are ways around that too. But if you can't easily talk to the dbus, then you're not talking. You can't run systemd commands under that user. So this is extremely simple, almost as simple as sudo su. So just forget about sudo and let systemd, or forget about su and let systemd take over yet another thing there. So, but I mean, yeah, this tool works great. I use it all the time. Just a quick example of how that would be used. Machinectl, shell, containers at, there you go. So if you haven't caught on yet, I'm showing you how to do this stuff manually, and then we're going to get to the Ansible part. So I'm giving you a little bit of both. Like this is how you would do all this stuff manually, and then Ansible. Got a question?
On machinectl, does the user have to have a valid shell?
No. After this, you can put the shell. Not at shell, but you could do. You could actually do any command after that.
I was just curious because, like, if you did the shell, so there could be like fish or something.
It can, yes. I don't know if it's in the GIFs, but that's what I do. So I would do containers at space / user sbin fish. I think that's what it is, right?
Okay, yeah, user bin, yeah, whatever.
Mm-hmm. Yeah, so you can put, and I think you could put any executable past there, but it's after the space. But it's a space and then the thing. It's not after, right immediately after the at. I believe. I don't know how to use the tool other than this. I believe at is for a host name. There's some measure of remote connectivity machinectl can do. So.
And you're right, it's part of systemd container.
Oh, there we go. It is part of systemd-container. So perfect. Okay, so running containers with Podman. You guys already know how to do that, but we got online people too, so we'll just talk about it briefly. There's two main ways, or at least two only ways that I know of, is run and compose. We're focusing on Podman run today, or Docker run. So if we have Docker run commands, they're fairly straightforward to translate into a Quadlet file. If you have a compose file, there be dragons, as somebody else said earlier. Yeah, I mean, there's tools to, I think, Quadlet, or not Quadlet, Podlet is a tool that you can use to translate, but I didn't even put it in here because it acts so weird sometimes, it's not even worth. It may not even be worth trying. However, you can use that as a starting point, potentially. But yeah, the compose file, there's other tools to translate those back into run commands, but your mileage may vary. Does anybody have any questions about that? Okay. Okay, so before we do that, all right, let's just see. I forgot what this command's going to be, but so we're going to machinectl into our containers user, and I think it's just podman run. Yeah, I'm running a WordPress container. So I'm probably not going to go into detail. You guys have seen the running containers, I run it, we check container list all, there it is, we're stopping it. Nothing special here, nothing with Quadlet yet. This is just regular Podman usage, starting and stopping a container.
Yeah, you had mentioned earlier about needing systemd linger and netctl. When does that come into play? You had mentioned systemd linger and sysctl earlier. When does that come into play? That has to do with the automation side, correct? Not with the manual runs?
No, that has to do with the manual runs if you expect them to persist after you log out.
Oh, okay.
So if you start a container and then log out with or without systemd service, it's going to kill it eventually. It may not be at first, but it will kill it.
Okay.
So, and that goes with a systemd service, that goes with a Quadlet, that goes with basically anything that the user's running. So, and then the sysctl, that's global for the whole system. So again, not with automation, not with Quadlet. If you want to run a container at port 80 on an unprivileged user, you're going to have to change sysctl. So that's why it's kind of the order of doing this. I think if I didn't do that, we would have seen an error on this. I think it would have complained that it can't bind to the port. So when I ran as soon as I ran the container, attaching it to port 80. Or let's see, I'm just looking now, I'm curious. I guess I didn't attach it, but I think it attaches itself. Yeah, you can see, and it would have complained. Okay, all right, so getting started with Quadlet. Quadlet files are very similar. They're reminiscent of a systemd service file. There's a lot of, they basically are a systemd service file, just with special sections in there for Podman. And then once they're in place in the directory they're supposed to be, and we'll talk about that later, systemd will parse it, and then once they're parsed and they're valid, then systemd will create the corresponding service units, or service, not files, but services for you. But I think I mentioned it later, but these are transient. So when they get generated, they're transient services. I think we'll go into detail about that later. So this is a basic, I'm going to show a Quadlet file, but this is the basic breakdown. There's a unit section, just like systemd service file. There's an install section. Has anyone here written, are we familiar with systemd service files? Mostly? Okay. So there's various things. We'll see in the examples what's under unit. Mainly the pod and the container parts are the important ones. We'll have a few examples. I'm not going to cover every option under pod and container. The systemd or the Quadlet man page shows all of the options. So we're going to be looking at like the pod name, port settings for the pod, and then container names, environment variables, what the image is. I believe that's it. Maybe a few other things. And then the install section, again, is just not, this is back to systemd, right? If you want it to start on boot, you have to have the install section. Okay. So this is the pod. So this is a Quadlet file for WordPress.pod. I've added a few things in here. Well, let's look at the Podman part first, right? Pod, it's pretty self-explanatory. What is the port we're publishing? This is the same syntax you would see in a Podman run, 80 to 80, and then the name, again, self-explanatory, right? The name of the pod is going to be WordPress. The last section for install tells systemd we want this to start when default.target starts. So we want it to start at boot. Up at the top, a little more complicated. For those of you that are in the know, this is not actually the valid name of this. I made it. There is a bug I didn't cover in this presentation, but where apparently systemd user units can't actually interact with systemd system units. So they had to do this whole entire workaround about creating a special service for waiting for network to be online. In the meantime, people were encouraged to make their own. So that's what I named it. That's not the one that systemd. I think the systemd one is just network online, I think. I'm not going to cover that because they're in the middle of fixing that. So, but you get the point, right? We're waiting for this service to be ready, and that this service is ready when the network is up, basically. I'm not covering Podman auto update also in this, but we are calling in. So in the want sections, we're calling these services. We want them. And then you can see we can ask for before and after. So I want this service to start before WordPress-app.service and then the db.service. So we request them with the wants, and then we tell systemd we want this to start before those two, not after, because they will fail to start if the pod's not there. And then the same thing with after, right? We want the pod. We asked for networkonline.service, but we want the pod to load after network online, check network online loads, because the pod might fail to bind to the ports if the network's not up. So these are just hard-learned lessons. This is just an example. You don't have to do this. It might work on its own, but this will make sure that the network's a little more stable.
Okay, I just looked it up.
Yep.
As a follow-up to being able to do IPv6 and the lower port forwards,
Yep.
even though it says IPv4 in there, it
applies to 6.
Applies to 6.
Interesting. There you go. Problem solved automatically. Thank you. Any questions about this pod? I mean, most of this is systemd stuff at the top, right? The only thing here, Quadlet specific, is the pod configuration. Everyone has a firm understanding of what we're doing in the unit section. It's pretty self-explanatory. Okay. So here's the WordPress-app.container. We're doing more of this ordering stuff, dependency ordering, right? In case this service is started on its own, we're asking for the pod and the database. And we also tell it, I want to start the container after I want to start the app after the pod and after the database. I don't want the app to come up before the database because it might be fine. It might just wait, or it might say, I can't get it, and it might crash. I don't know. Maybe it'll restart on its own. Again, we're trying to make it bulletproof, right? So this is the ordering is important. And then this is an interesting one. I only learned of this one recently, but part of ties this service to the pod service. And that means if you restart the pod service, the child services like this one will restart also. So this is not about dependency or ordering. This is about tying them together as like a single unit deal. So that comes in handy. Again, some of that may not be necessary, but this makes it pretty robust or pretty reliable. And then the container stuff. So most of these things you would see in a run, right? There's the name of the container, the pod. This would be like, I think it's dash or dash dash pod. I don't remember, but these are. If you had a run command, you could translate that right easily into here. So these hopefully are pretty self-explanatory. The environment files, these are specific to WordPress. You just find them, on the Docker Hub page for WordPress. The image. And again, I'm not going over auto update, but you call it out here. So what I would do in order to make this, there was no reference for this. So what I would do is I would start at the Quadlet man pages and then just figure out what you need.
Is there a better way to inject passwords in other than hard coding them in the text file?
Yeah, you can pull
inject them by environment.
Yes, well, you could do that. Although you'd have to put it here if you're doing it by environment. But I think I did it once, not in this presentation though. I think systemd can load the environment from a file. If not, I know that Podman can. So I don't know the argument that goes in here. I would start at the Quadlet man page and see there. So, but you could take, this would be an example if you just had this as a Podman run like we did earlier, except I didn't have the environment files. I would start at the Quadlet man page and then just see like, okay, how do I translate these into what I need? Every single part of that run command, go to the Quadlet man page and just look. And that's how I would do it. Like if I was starting from scratch, that's what I did to make these. And then the database. Nothing's new here except it's now MariaDB, right? So tying it to the pod. This is actually an important thing to note. This continues to trip me up every time I do this. This is the only thing that's inconsistent about this, about Quadlet, is instead of just saying the name of the pod, you actually have to do that. You have to say WordPress.pod, or else systemd doesn't understand what you're, it doesn't know how to tie them together, and you get some really funky error. I think the last one, yeah, I did it there too. If you just put WordPress or whatever, like the name of the pod, this will not work, and you will not get a clear message. You'll get some weird message. So that, I would say this is the only the only part that's not potentially obvious about this. Because everything, I understand it up at the top, right? But everything down here seems to be just the same exact thing I would type into a Podman run, but I would not type .pod into a Podman run. So that's probably the only part there that's not clear. Okay, so what do we do with these files? We've made them. What are we doing with them? There's two different locations for Quadlet files. The root one is there, and so is the rootless. We're not talking about rootful, so I'm not going to mention this past right now. But you could put the Quadlet files there for if you wanted the systemd to do it, the Quadlet. Otherwise, it goes in your home directory in that directory. And you'll see a lot of the systemd commands we're going to run have the user, --user in there. If you want to do rootful Quadlets, you just take the user out, right? So like systemctl daemon reload instead of user daemon reload. So this, and unfortunately, this is the only way to run this. This is the tool that systemd uses to translate Quadlet files into systemd services, because they're not files. This is their generator, for lack of a better term. I mean, that's what it's called. When you run this command with the -- user and then the dry run, it looks at your Quadlet files and then it spits out what the corresponding systemd service files would look like. So your little Quadlet's going to turn into this large thing. If it spits it out, if it just dumps all this text on the screen, then you're good. You did it. If it spits it out and then it has an error, then that means that it could not read the Quadlet and they're not going to run. So it is useful because it's important to understand the flow to this. If we don't have automation, the flow is I make these files, I put these files into this mystery folder, and then I patiently wait for systemd to do something about it. Or maybe I'll reload the daemon, and then I'm waiting for systemd to do some magic. It's not going to come up and tell you, I did it or I didn't do it. You have to go look, did the services start? Did they get created? Is there an error? It's not going to tell you if there's an error. So this is important. I would just run this after making any new Quadlet files. So that is one of the reasons why we're going to do automation. But that's how you would do it manually, is you just drop the files in there, reload the daemon, check to see if the services come up. If the services don't come up, they either the container crashed because there's something wrong with your files, or it didn't like the Quadlet, but you don't know that it didn't like the Quadlet unless you do something like this. So this one's handy.
Now going with the, you made your Quadlet, you got it all together, and then it goes pear-shaped for you. Is there a log somewhere that we can go back and double check, or is it just fails?
If it's a syntax problem, I'm assuming the journal probably has it. I don't know. Okay. That's a great question. I never checked if the journal has it. I'm assuming it does. That's why I would run this anytime I'm authoring a new file. However, if the services were created, but then something's wrong with your container, you definitely can use the journal or systemctl status systemctl user status and then the name of the service, and you can see the journal output. And there's a way to look at the user journal too to see why. So if the container actually got created and then crashed, the journal will have the log of the journal for that service will have the log of why it crashed. If it didn't get created, I don't know. So start with this command. It's useful.
What did you say the second command was if it did start and crashes?
Journal control.
Yeah, I think we have that in here. I believe it's in here. And if not, then I failed. I'm just pack up now. I don't know. Everyone in the last presentation, all the speakers started excusing themselves at 5 o'clock. They're like, it's 5 o'clock. I don't know anything. I'm just doing this. So my excuse is it's 6:30 now. So yeah, I don't know. I'm not sure, but we'll see if the journal stuff is in here. I think that it is. Okay, so once we've parsed it and they are happy and you've run the daemon reload, systemctl -- daemon reload, then the next step is just to start the services. So in this case, ours would be -- user start WordPress -pod.service. And like I said earlier, I'm mentioning it here, the Quadlet generated systemd services are transient. So they can't be enabled, so that you don't need to enable them. They will just start. As long as they were parsed and they've got the install section, they will start. You don't enable them. I think it fails. I believe it fails because there's no symlink to be created when you try to enable them. And then the removal. If you remove the files and reload the daemon, then the services vanish because they're transient. If they're running, they hang around till you stop them, and then they vanish. So it's important to know if you're if you're like bringing it up and tearing it down, and then you delete the files because you're like trying to make your own automation or doing Ansible or whatever, and you remove them, but you didn't stop them, they're still going to be there. So that might be confusing when going to start something else. Maybe you rename them and you're trying to use the same ports or something, so that could just be confusing. Oh, here we go. We're going to run through this run, but I don't know exactly. So here's our Quadlet files. I'm making the systemd Quadlet directory in the user in the user home dir. I'm copying the files into the directory. I'm running the dry run. It dumped a bunch of text you can't even see, but there was no error. So that means we're happy. So now if I reload the daemon, the services should have been created. I can see, I can status. Here's the service, but it is stopped. It's not started because we never started it. And it won't start automatically the first time. And now we've started it. So there's the status using the systemctl user status. And then Podman container list all will also show them up. So I'll let that, I know that's kind of fast. I'll let it play through again. I don't know. Does anybody have any questions about that process?
Does it auto-enable the system CTL?
If the question, does it auto-enable the, only if you got the install section in the Quadlet, then it will. You know, at the bottom of the file, like where it would need it to be on a regular systemd service file. You just can't run enable because they're transient. The actual service files don't exist.
And when you run the generator, you have to have the dry run flag on it, or could you just omit the dry run and just do a -- user?
If you do that, I believe that's what systemd does itself. So I don't know what happens when you do that. So I would probably just do the dry run because it's doing, when you do the daemon reload and it sees files in there, that's what it's doing. It's using that same generator, and that text that appears, that's what it's using to create the transient files. So that's using its own, like we're like hijacking its own process basically. So I wouldn't run it with anything other than the dry run. The daemon reload will do that part automatically. Okay. So we talked about the manual process. So how can we automate this? This is a project that I've been working on. I call it Pod Playbook. You can do it, you know, I've showed you the manual steps. So as long as you know Ansible, you could do this yourself or using any other form of automation, bash script. I know someone that wrote a Python script to do this. And I was like, bro, I already did this in Ansible, but he did it in Python anyway. But, you know, that made sense to him, right? During the learning process of doing it manually, like, okay, how can I automate this, right? And it's part of the learning process. So do it yourself. This is an example of how I'm using it. So my automation here, it can configure the host and the Quadlet and Quadlets. So I think that's very powerful, and we're going to hopefully see that in a minute. So you can use this automation to create users, enabling ports on the firewall, setting the host name, time zone, firewall rules. I think I already said that. Mounts, and then all the Quadlet stuff that we just saw. So this is an example. What slide are we on? Yeah, okay. This is an example, a YAML. This is an inventory for Ansible using for my thing. This is not anything about Quadlet anymore. This is for my Ansible automation, just for the Quadlet part. So we are calling out where the file or where the folder where we're going to put all of our Quadlets, and then the name of each one, and then the file of each one. So I don't know. Some of you guys said you're all familiar with Ansible. Is that pretty straightforward? Any questions? Okay. I honestly forgot what this one does, so let's see what happens. So we've got our inventory. I think we're going to run Ansible. Yeah, so we're gonna pull down my project and we're gonna run Ansible not against the host, but just against the Quadlets. So we've already machine CTL'd into our user, and now we're gonna use Ansible Playbook, calling our WordPress.yaml against, yeah, there you go. So Ansible just did what we did manually for minutes or whatever. It just did it right now automatically. It did the exact same steps. It took our files, it made the directory, it took our files, put them into the proper directory, it ran the dry run, it started the services, and it actually waited. I don't know if that was clear. We'll let it run again. It waited until the services were either active or inactive, not failed, and then it continued. So if you have an automation, either using my project or something else that does this, this is going to reduce your troubleshooting of making a new thing, right? It's going to decrease that substantially. Because if your container failed, then it's going to fail at the waiting for the services to be active or inactive. If you have a syntax problem in your Quadlet, it's going to fail at the dry run part, because it does that too. So it did all the steps we did manually, and it did them automatically much faster. And you could just quickly iterate on this process, right? Edit the file, run the Ansible, what happens? edit the files, run the Ansible, what happens, right? So are we good with this? Okay. Okay, so we're going to scale this up. Because Ansible supports machine CTL as a privilege escalation method, we can automate the exact steps that we took. Because the one I just showed you right now, we were in the containers user already running the Ansible locally. So now I want to run it remotely. That's one of the steps of configuring the host remotely. I want to run this remotely, right? I don't want to log into the box, log into the user, and then run the Ansible. So we're going to, because Ansible can do machine CTL, we can do this completely. Because if we use the regular become method that Ansible does, it won't be able to talk to our systemd, just like we wouldn't be able to do it on the command line. So, okay, so the example environment here, right? We got one cloud VM. We have a block storage volume attached to the VM. The volume is going to be mounted at /home/containers. So all of our container data, all of our Quadlets, all of our files for that container user are on this external volume. So we're setting this up for the host to be completely trashable, right? Like we keep the volume, we trash the host. That's what we're hoping to do. And then the WordPress pod and the app and the database. So I'm going to let this scroll in a minute. I have a full-size inventory of what this would look like. It's going to scroll. It's not, I'm not expecting you to memorize it or whatever. The examples are in the GitHub if you want to see it. So I'm just going to let this play. But this is what, like, an example of using my Ansible automation of what you could do. So we're setting the host name. We're choosing the user to log in as for the automation. I'm not going to be able to explain it as fast as it's going, but you guys can read, right? So you can kind of see in general what we're doing. We can completely configure this host using this, or at least all of the ideas that I've come up with that I need for my hosts. So the first part was the host, and then the second part was like the Quadlet stuff you guys have already seen. I'll let the first half run through one more time. So like we're setting the host name, we're setting the patching stuff, and you'd have to look at the code to see exactly what the auto patching is doing, including the SSH hardening too. Setting the time zone, setting the firewall services, making sure host packages are present like Git, doing the unprivileged port start, we're setting it to 80, doing the disk mount, this is a Linode disk, and then everything past that is Quadlet. So the idea, I'm going to wait so you're not distracted. So the idea is I want to be able to completely rev an entire machine. I want to be able to install a brand new Fedora server, run this automation. 5 minutes later, the containers work over here now, and I just shut the other host down. Or I can move the mount. I could do whatever I want with the data, move the volume from one machine to the other. But the idea is I want the host to be completely replaceable. I don't want to do any of that stuff ever again manually. So here is us configuring a host from scratch, completely from scratch, just using the host automation against that inventory you just saw. So you can see we're setting the host name, setting the mounts. It's actually mounting as well as setting the FS tab. Installing packages, unprivileged ports, reloading sysctl after the port's changed. It created that network online service. So we didn't talk about that, but it created the service for us. Doing the linger stuff that it just scrolled by way too fast. But I want to stress in this amount of time, like I've literally just configured a host. Like it's done. Some parts were accelerated because I pre-staged the packages, so DNF didn't have to think too hard, but we literally just configured this host. And then now I'm going to configure the containers that are already mounted in that disk, right? The block storage that we mounted. And this is basically kind of what you saw earlier, but now we're running it remotely against the box. We're not running it locally. Now, in theory, for those of you playing along at home, in theory, we shouldn't even have to run this second one, because if these containers already existed in that mount, as soon as the mount comes up, systemd will see that mount and will see the Quadlets and everything will start. So this is actually unnecessary, but I wanted to do it again anyway. So that's how actually fast it is. As soon as that first Ansible runs, your containers are back up, assuming you had containers to begin with. So there you go. In under 5 minutes, we configured the host and our containers were started. Yeah. And yeah, I already said about the time. The time is going to depend on how many images you have, or I'm sorry, yeah, image download speeds. If you actually are building containers, or if the stuff already existed, any new packages that need to be installed or were already there. But so that inventory file, we're thinking about one box, right? But now think of like a fleet of boxes, right? You could do this very easily, or a fleet of containers on the same box. Again, it scales in either direction using that inventory file. And that's it. We made it to the end. Does anybody have any questions? Yes.
It's about flexible, non-expensive, yucky cloud storage.
Mm.
Would you use DRBD? Because cluster's going the way of the Dodo. I know there's Ceph.
Yeah.
What would you use for a distributed file system to store your ephemeral, your non-ephemeral data with your ephemeral hosts?
Yeah, I mean,
without using the cloud. Like MinIO is gone because they're all mad on the licensing.
right. So we're talking about non-cloud on-prem?
Yeah. Well, no, just in the cloud. Like I don't like to use the cloud. I like to use multiple providers because I don't trust Scamazon or
right.
I just like to do stuff myself.
Yeah. I don't really have. I wasn't prepared for that question.
Okay.
And yeah, I mean, I've found that, especially like with Linode, like I'll just use their volume storage, and I haven't been burned yet. But,
okay.
But I could definitely understand and see the need of wanting to like put a layer on top of that, and then potentially potentially utilizing other services or other providers at the same time. You don't want to be locked in.
I think DRBD would probably be the easiest. It actually lets you have remote disks and synchronize them across the network. Anyways, that's just what I would do.
This method that we did, other than the Linode storage, right? We have that could just be changed to anything. So I did this with like a physical KVM disk I was testing. So I mean, we're not locked into anything there. So yeah. Any other questions? Yep.
This is kind of a random question, but have you messed around with Blue Chi? I think it's, or Blue Kai. I don't know how it's pronounced.
I don't think so. What does it do?
It's basically where you can like systemd run a service on another host.
Oh.
It's like a multi-node systemd overlay thing.
I have not, but I bet you maybe $5 that machine CTL's in there somewhere, because I think that's what it does. I think that's what it can do just manually. Like that's how you would do it from the command line. But no, I have not. It sounds pretty cool.
I think with Ansible and Quadlet and getting all that together, you
that
can
might
build,
be
a monstrosity.
Yeah. Yeah. We did it.
Have you published to Ansible Galaxy?
I have not. I'm afraid to. This is the first step, is getting, it is on GitHub. So yeah, I don't know. I have not yet though, but thank you. I might. That is true. Okay, I'm good if you guys are good. Yep. Thank you.